This is the second lesson in Revit. We did a quick and dirty drawing of the basement perimeter column. This is a very imperfect column array, but this is just to demonstrate how we're going to go about doing it. Now, let's try to get some elevational data into this model. In Revit, by default, generates a level 1 and level 2. The walls and columns we do are unconstrained to levels right now. They're unconnected and they're all drawn at 20 feet. Well, maybe the columns. Let's see if we can choose a column. The columns look like they go from level 1 to level 2. Anyway, there's some images that we have that we've collected from a building permit search for the city of Boston. And one of these, there are several images. One of them has a quick overview of the different floors in the building. And actually, now that I think of it, it might have been easier to work from images of this to where, see how they simplify all that stuff that we were drawing around. But what we'll do is just look at the elevation. Oh, and this is data that we collected with Walter Johnson at the front of the building using a scanner. So we have a bunch of information that we're going to use to construct a model. So I'm going to bring in that picture. This is a drawing I want to bring into the elevation. So I'm going to insert an image here. I've already identified them as this page 2. Alright. Oh no, that's not the one I want. Image. Page 3. Nope. Let me go back to the drawing board. Let me pause this and I'll find it. So I opened up an east elevation, and I'm going to place an image. And the image I want is this page 4. It's a bitmap image, so we're going to have to scale it. But this is going to be pretty easy because we have these elevation bullets and a distance, and we're going to say from 1, this appears to be an elevation from the ground floor. And you're wondering, why does it say 1, elevation 88.3? Because these are what are called absolute elevation datums, so they're measured from sea level. So this building is 88 feet, this level 1 is 88 feet from the surface of the water of the Atlantic Ocean. So 88.3 is 1, 215.0 is the roof. That means 215 minus 88. I need a calculator to do that. 215 minus 88. Let's do that first. 127 feet. And then the difference between 3 inches and so that's 127, 126.9, right? So that accounts for the 3 inches. 126.9. So I'm going to select this image, click on Resize Scale, measure from here to that point, click on where that point, and now type in the value that it should actually be, 126-9. Enter. Let's see what we got now. That's cool. So if I take this image and switch to wireframe so we can see through the geometry we've already created. If I take this image and say level 1 and line up with level 1, right? I can get absolute measurements I can create similar datums. I select the elevation, right click and say create similar. So now I'm typing datums of each of these floors. Notice the values are, my values are relative to the first elevation that was created in the drawing. So I'm just moving along level 5, level 6. Seven, 8. We don't need to model the entire building, but if this will just help us later as I go. We can make this available to people if they want to study it and understand how I went about doing this. 11, 12, and the roof is, as we expect, a little over 126 feet. 3-inch error. So we have all the levels. Okay, let's start. One of the things about grid lines, I'm going to open up some of these additional elevations. Yeah, in order to see them at other levels, you have to extend them past. So I'm just pulling. These were 1, 2, and 3. I think these are the horizontal ones we did. So if I go to a south elevation, west or east, you see the other grid lines. So we have to take, it's so hard to select these handles. We have to drag them up through the levels we created so they're visible on those levels. Right? These are in 3D right now, so I'm just placing them where I can see them. Some levels that weren't aligned with each other. So Revit usually creates alignments and line constraints when you draw these. So why am I doing this? Because this allows me now to travel to, say, the floor plan for level 10. Right? We don't have any information here yet. But we know that if we were looking at level 1, the walls and columns, and let's just arbitrarily select these 4 columns, copy them to the clipboard, and go to level 10, paste, aligned to current view. This is what we have going on. Level 10, we don't have the drawing yet for level 10 as an underlay, but we do have a level 10 drawing in AutoCAD. You're going to find that images, sometimes images are easier to work for than the CAD drawings themselves because the images are abbreviated, they simplify. But I'm going to link CAD drawing of what I, okay, so they have a level 9 and 10 drawing. Open that. Again, what am I doing? I'm going straight to level 10. The upper floors slightly different in terms of layout. I'm not sure what it's taking. Okay. I don't know why that took that long. So when it places a link, it pins it, you have to unpin it. So you see what I'm doing is moving into place. Now I know that that grid line aligned to that line, so I'm going to take the align tool. And it's aligned to that element, this line. And then the one going across, I'm fairly certain is number 4 here is going to correspond with I in this drawing. 4. And we're going to use that to align it that way. Does that seem right? My columns were here somewhere. No, in the middle of the room. Let's go to level 1. Let's see where we went wrong. I'm just going to take this wall, copy it back to level 10, and paste it in. Paste it. Align to current view. That's what's wrong. Have to align so in this direction. I messed up. That grid line so let's do a line again. So that grid element that we created corresponds to that grid element. There it is. Now we have the columns appear to be drawn in correct. Let's go ahead and draw a couple of them. Oh, not level 11, level 10. Top constraint invalid. Top constraint is level 11. Okay, yeah, because I'm doing there's a column there, column there. Just like that. Mm. This can't be right. Sometimes you get CAD drawings that are not quite accurate. Let's move that. So I'm drawing without drawing grid lines, but I'm just drawing on top of the CAD drawing. There's the front desk, and yeah, there does seem to be a problem there. I think we discovered. Problem. There's one at by each of these elevator bays. And the size of these elements are a little larger than what actually exists. So we're going to be designing around the columns. I don't remember if I'm still recording or not. Okay. Stop.